All right then, so the feasibility. Is it going to happen? Is it not going to happen, my chemical reaction? Well, let's look at the metals first. So you don't actually have to remember the reactivity series for metals. The IB specifically says that in the syllabus. So this is one I pulled out of a book. The most reactive at the top is magnesium. Least reactive is silver at the bottom. So magnesium's the most reactive metal. Metals hate electrons. They're electrophobic. So that means magnesium wants to lose electrons relative to the other metals. So magnesium wants to oxidize, and so magnesium's a good reducing agent. Whew. What a long way to get there. So don't forget this. The most reactive ends up as an ion. That will get you almost all of the way through these sort of questions. So here's an equation. Does that work? Is that feasible? Yep. Iron ends up as an ion, and it's more reactive than lead because it's higher in the series. Is that true? That's a no reaction? Yep, copper ends up or remains an ion. It's higher than silver, no reaction. And the third one, well, the third one isn't possible because iron is not the most reactive. Zinc is. So that is not feasible, that final equation as written. So how would the IB ask these sort of questions, and what sort of explanation would they demand? Well, here's the classic. Zinc and copper sulfate makes copper and zinc sulfate. Does that happen? Well, zinc ends up as an ion, and it is the most reactive compared to copper. Fantastic. So that is a feasible reaction. The IB might ask you, what do you see? Well, copper sulfate, that's blue. You're supposed to know that. Zinc, well, that's a silvery metal. Shiny. Copper's brown. And zinc sulfate is colourless. You don't need to know zinc sulfate is colourless for SL anyway. So the blue colour fades of the solution, and the shiny metal seems to be coated in brown solid.